Okay, hi everyone. Thank you for attending this evening. Welcome to CNYC's Local Law 97 Sustainability with Affordability series. My name is Rebecca Poole, and I am CNYC's Director of Membership and Communication. For those of you new to CNYC, we're a membership organization dedicated to providing advocacy, education, and information for New York City cooperatives and condominiums. Since the inception of Local Law 97, CNYC has been working hard to advocate for incentives in place of penalties, common sense, financial hardship clauses, and an understanding that financial feasibility is a critical component of the overall picture. We're thrilled to be able to present a class tonight on the electrification of domestic hot water heaters. As you'll learn from our instructor, depending on the system in your specific building, this may very well be a project that has a reasonable payback period and will help you reach compliance into the future. Before I introduce Sina, I'll ask you to put your questions in the chat, and Sina will stop at natural breaks to answer them. There will be some additional amount of time at the end for Q&A, so if we haven't answered all of your questions by the time we get to the end, feel free to put them in then. Sina will stay a little bit afterwards to answer those questions. I'm happy to introduce our speaker for this evening, Sina Jasteh. Sina is the founder of Efficity and a professional engineer with more than 9 years of experience in HVAC and water heating system design, energy analysis, and consulting. He's a licensed professional engineer in mechanical HVAC and refrigeration, as well as a registered design professional. He's also a certified energy manager, an ASHRAE BC XP building commissioning professional, and is certified for LEED. Before devoting his time fully to Efficity, Sina managed the multifamily clean heat program for Con Edison in New York State. His program paid tens of millions of dollars to multifamily residential buildings across New York City and Westchester to fund projects to replace fossil fuel heating systems and move to electric heat pumps for both space heating and hot water. He was a senior account manager and engineer for New York City Accelerator Program, where he helped more than 30 multifamily buildings analyze their energy use, calculate emissions, and navigate pathways to comply with local energy laws. Before that, he designed heating equipment for Rheem, one of the largest HVAC manufacturers in the United States. I'm thrilled to introduce you to Sina. The floor is yours.
Thanks, Rebecca. Hi, everyone. Very glad to be here with you and share my expertise in hot water heating and heat pumps with you this afternoon. Hopefully it's useful for you. A little bit about Efficity. So as Rebecca said, we are energy efficiency and engineering consulting firm in New York City, and we specialize in local law 97 compliance for multifamily building, especially heat pumps and application of heat pumps to space heating as well as water heating. So full or partial electrification. And we'll talk about that in a little bit. We are a Con Edison participating contractor and New York City service provider, New York City Accelerator service provider. As part of our services, we provide incentives through Con Edison programs, as well as NYSERDA, and we can claim tax credits from different channels such as IRA for the projects that we do. We are a licensed professional engineering firm, and we can do the full DOB filing, permitting, and inspections for all the projects that we do. And for that, we can offer turnkey solutions for water heating, soup to nuts, basically the whole package. So it's a convenient way to get started. So the type of buildings that we usually help and the projects that we have 4 electrification projects right now that we're working on actively. They're all multifamily and they're all heat pump projects, both in water heating and space heating. The buildings that we usually help, they're either facing fine from local law 97, they want to reduce their emission, or they have low energy grade like the ones that you see in front of your building, and they're looking to improve that. Or they have a lot of high energy bills, both from the apartment side or the common charges are very high, and they're looking to reduce that. We help them take advantage of the incentives while they last, and that's a big motivation for a lot of the buildings to act sooner than later while these incentives last. Typically, the buildings that we work with are on the larger side, more than 20 dwelling units. The larger, the better, I always say. In terms of cost, it just breaks down much easier per dwelling unit once we scale up. So this is the basically breakdown of how the energy is typically used in a multifamily building, and we're focusing on this 25 to 30% portion that is related to water heating in this seminar. So how do we get started with Efficity? How do you get started? You call us. We talk about your goals. What are you trying to achieve? We talk with the whole board in your case, and we visit your building. We walk with you. We do an initial assessment. We analyze the information from public sources as well as what you provide to us, such as utility bills, any drawings that you have, and then we, based on your needs, based on what we advise, we provide a proposal for you that can either be turnkey or in a more traditional engineering and bidding structure. So we are flexible on the path that you provide, but most of our clients, they want to have basically a one-stop shop solution, and we provide that to you. So along with the proposal, we provide estimation of incentives that you can get, the tax credits that you can claim, the running utility costs when we install the equipment for you, how much you would pay per month for that equipment, or in electricity, how much emission you would reduce by doing that project, and how much fine you would avoid by doing the project, and a simple payback based on all of these factors that we just talked about. It is a typical process that we go through once we're starting a project with a building. So we're talking about water heating and heat pump water heating specifically here, and we believe that's the best first step towards electrification and decarbonization of your buildings. And why do we say that? It's because 30% of the emissions typically for multifamily is coming from water heating. This changes based on building size, but that's typically around that number. And it's the most easy but also very impactful way to reduce your emissions. It's low disturbance to the tenants, to the occupants. You wouldn't even notice people are working in the building. There's nobody's entering apartments. There's no scaffolding needed in most cases. And when the switch over to the new system happens, there's no downtime for your water. You wouldn't even notice this work was being performed. It's relatively fast compared to the life cycle of these projects. Rather than years, it would be a matter of months, a few months. A much lower capital cost in terms of it's not a huge burden on the building. A lot of the buildings can fund this with their reserves, and we can provide financing. If somebody needs financing for their project, we can provide that as well. So low disturbance, low capital cost. And one of the things that we hear a lot is that electrical upgrade, or we have to upgrade our electric, we don't have power. In most cases, and we talk about this in more detail, in most cases, buildings have enough or heat pump water heating only, that upgrade, because it's not such a significant power draw to your building. So if you do want to upgrade your space heating, that's a different story. But water heating alone does not need upgrade in most cases. So typically in most buildings, hot water is part of the boiler that is in the building. It's a section of the boiler, and we are proposing a new system, which is a heat pump, and just putting visuals here for you to better understand what we are talking about here. So they come in different shapes and forms, different sizes for different buildings, from very small to much larger, and they're modular. So some of the myths that we hear a lot in the market about water heating, and we want to talk about why these are myths. They're not true, one by one. We have to upgrade our electrical service first. So that's, again, the systems that we design. We design them for low power usage. They are full heat pump, year-round operation in heat pump mode, and they do not require a lot of power. And we can show that later, that the power they draw is, in most cases, is well within the capacity, the extra capacity that buildings have already. The running cost of heat pumps is going to be higher than our current system. Again, the water heating system in most buildings that we have in New York City is really wasteful, and that wastefulness is a source of high utility bill for most buildings. Heat pumps are carefully designed for reducing waste in energy use. So that reduction in waste make the running costs much more competitive compared to others. And again, we have charts later in the presentation that we talk about this in more detail. Heat pumps don't work well in cold days, and we are going to run out of hot water. Again, not true. In the past, I would say decade, heat pump technology has advanced significantly, especially in the past few years. There are many more variety of cold climate heat pumps. When I say cold climate heat pumps, it means way up north in Canada, they provide full capacity, hot water. I'm talking 190 degrees hot water during the coldest days of the year. And that's how good they are these days. So this maybe 15 years ago, 10 years ago, that was true, not anymore. There will be a lot of disruption in our everyday activities. As we said, you wouldn't even notice it. It's too expensive. With the incentives that are in place, the cost is competitive to, let's say, a traditional gas or oil system. And that's why these incentives are there, to make it competitive. So you would go with these systems instead of gas systems. They naturally are a little bit more complex, and they cost more, but the incentives will offset that extra cost and make it competitive. Water heating has to be upgraded with space heating at the same time. Again, two different systems. They have nothing to do with each other. One is completely separate from the other, and they don't use the same type of equipment. Nothing is shared between them, and they can be done at different times. We have to remove our existing boiler to install heat pump. That's not true either. You can decommission the section of the boiler that is using for hot water, but you can still keep your boiler for space heating and supplement it with your heat pump. So there are two different systems, and we can supplement while you're considering or not considering upgrading to space heating. We talked about the boilers. This is a Scotch marine boiler, very typical for larger, mid-sized building. in New York City. They provide steam heat to the building, and they do have a coil on top that they provide hot water heating using that coil. The problem is that this whole boiler has to come on, produce steam, produce heat, just for you to get some hot water if you don't have any need for heat at that moment. And that's where the waste comes from. When I said these systems are really wasteful, the existing systems, this is the source of waste in most cases. This big boiler has to come on because somebody in apartment 2B opened the tap, and that's really, you can imagine how wasteful that can be. So I want to talk about electric systems. Again, not all electric water heaters are the same. Um, there are ones that are fully heat pump, and I talk about how heat pumps work. And there are some that are fully, I would call them electric resistance. There's a heating element inside, and there's just electricity goes through that, and the heating element gets hot and it heats up water. And there are some that are somewhere between the two, the combination of the two. So what we specify, what we design for in our applications is this one on the left, the heat pump only, no electric resistance. And we talk about why we do that. So just a little bit about heat pump water heaters. They take air, a relatively warm air. I mean, again, this is a relative term. So this air coming in is warmer than the air going out. So it takes in air, it makes it colder, and extracts that heat, whatever heat is in the air, and gives it to water. And this water, again, it can be as hot as 190 degrees. So we bring that heat down to make it safe for your use, but it can produce uh, as hot as 190 in negative 17 degrees temperature air. And cold water in, hot water out. The system on the left uses 3 to 4 times less power than the system on the right. So, and that's not only the amount of energy used, like the bill that you get, but also the electric infrastructure that you need. So if the service that you need in your building, if you have to upgrade panels, upgrade breakers, all of that, this on the right is 3 to 4 times more larger than the one on the left. That's why we don't specify heat pumps that have those electric resistance elements in them. The ones that you see a lot in the field, as they call them, heat pump water heaters, everybody looks at these. These are not good choices for most multifamily buildings. Again, if you have a small building, uh, there could be some cases that you may use this, but for the audience in this class, this is never a good choice. And we talk about this more. These systems don't operate in cold climate, so anything below 40 degrees air temperature, they go back to this heating element. And then again, 3 to 4 times more power is needed, and the infrastructure has to be sized relative to the power need of these elements. So that's why we stay away from this, to make the solutions that we provide to the building um, the most economical as well as the most efficient overall as a project, as a package. Lower cost, better operation, less need of space, and less need of power upgrade. So there are different variation of the systems that we specify. You know, some of them are in this picture. There's a wide range of systems available now, and we use a combination or a modular design for these systems. So again, bad practices. We see a lot of these in the field. you call a contractor and say, oh yeah, we install heat pump water heaters, and they do this. And you never want to see this situation. And I explain why. Because these water heaters, they need a lot of air. As you remember, I explained, they extract heat from the air and give it to water. Guess what? In this room, there is no air. I mean, it's just they're all sitting right by each other. There's no window. And this little box in here has to get heat from somewhere, give it to them to produce heat, and this is not what you want to see. Um, so cold climate, all of these will go back to the heating element that you see here when it gets cold. And in this room specifically, that's going to happen anywhere like 60 degrees because this room is going to get cold as these work. So they keep going back to this electric resistance, and you basically get no savings from these heaters here. So they won't work in heat pump mode. Most of the year they would work in their electric backup mode. And as a real world example, uh, these heaters right here, they consume 24 amps. They need structure for 24 amps. And the small heaters that we specify with the same capacity, they only need 7 amps. So imagine that is reducing your electric infrastructure in the same manner. So our systems are designed. There are many components in it that make them efficient. So we make sure that the components that we use are the most advanced engineering practices that are practiced all over the country, but also leading technology in terms of how we employ these technologies, these heat pumps. And we have different designs for different sizes of the buildings. And once we visit your building, we provide um, preliminary design as part of our proposal. We do some preliminary design to find out what suits your building. So each building has a different angle, so we don't have like one solution fit all. It's more of a matching the equipment and solutions to your building. I want to stop here and let Rebecca to see if there's any questions in the chat or anybody has questions about what we talked about to ask here.
So there are two questions in the chat, but I just want to make sure before we go on, the last slide that you had, you're going to explain further on, right? Like how the various items that are in the, that are in the system. You explain that later. I don't recall.
I will explain it here a little bit more. I don't want to get too into details of the engineering details of it. I think it will bore everybody if it's getting too technical. So, but the components in the system are basically a heat pump that would be outdoors. Definitely, we're not putting anything in a closed room. It has to be outdoors, so that's outside. And then there are components that need to be inside, either in a boiler room, around your existing boiler, or if you're removing your boiler, it would be in place of it, and storage tanks. So we need storage to store hot water and mix it down to your useful temperature. As you remember, I said these units produce high temperature water. We want to store them and use these tanks as a battery, basically. So these tanks will be charged, they would be used while your building needs them, and they would be recharged while there's no use. And there's a tank that if you have a recirculation in your building, we use a tank to keep the water temperature stable in your building for when you need it, and we are not running the heat pump when there is no demand, there's no shower running or any tap. This is like the overall uh, design of system. Again, this will change. There are many different small components, controls that is not here, but that's the overall gist of it. So again, from what you would care about is um, we have storage tanks. We have to bring the storage tanks in your building and find space for those storage tanks, and we need access to an outdoor space. So that outdoor space could be a courtyard, could be a backyard, or could be the roof, depending on what is accessible. We find that in a lot of cases, the most easiest path and the most cost effective is using a courtyard. And the city has new regulations that allows us to use these yards for these purposes. So it's a great time to start looking into these things because the city wants it and they're passing laws to help us do that.
Thanks, Sina. Okay, so we have first question is if the existing boiler is already separate from the existing hot water heater, how does that change the savings that you would get if you go to a electrified version?
Yeah, that's a good question, and we have slides further down. If you have a hot water, uh, a water heater, specifically designed for your water heating needs, and it's using gas, in most cases, the savings are not going to be that significant because those water heating systems are sized, in most cases, are sized um, for that need. So they're not oversized like the boiler, trying to do two things at once. So in those cases, um, if your only goal is to see savings in your utility um, and you're on gas, then you probably won't see that much savings. However, if you're facing fines, if you're facing local law 97 fines, then that's a different story because these systems will significantly reduce the emissions. Because if you're using gas or oil, the emissions would be 3 to 4 times less using these systems compared to gas. So you have that savings and it comes into the calculation.
Thanks. Is there a backup in case of loss of electricity? So if your electricity goes out, is there battery backup or?
Yeah, so battery backup, the battery backups that we use in certain cases are mostly for freeze protection purposes because some of these components are outside. These are for certain types of systems. So certain types of systems don't have the concern of freezing, and depending on the application, we use one or the other. And if the power goes out, then there's no other way to power these units. The good news is, in these cases, we have a lot of storage, as you remember. So if the power goes out, usually you have enough water in your tanks to give you hot water for, let's say, half a day or more, depending on your use. So you would be you have a 6 hour, 7 hour, 8 hours buffer until the power comes back and the tanks start recharging.
Many buildings have no yards and you'll need to use the roof, as you said. So how heavy are the heat pumps that have to be installed for the domestic hot water heaters? Do you have a problem with weight capacity when you put them on the roofs or?
Yeah, so that's a good question. So this is we install equipment on the roof all the time, and we have a project we are installing. It's an old building, 1800, late 1800 building. It's wood, and we are installing 21 VRF units on its roof. So there are definitely ways to support these equipment on the roof. We can use a parapet. We can fortify the parapet to support that weight. You can find the beams. These units usually are much lighter than space heating units, and they're much fewer. So in most cases, um, the roof can support the weight of them. Um, and the ones that we have different variety of them, that some can be mounted on the wall, and some can be mounted, basically placed on the roof. So depending on the case, we may choose one or the other.
Okay. How much noise do the pumps make, particularly in reference to putting them in a courtyard where apartments might be overlooking that area? And how much heat is given off by the exterior heat pumps? So I guess like in buildings like mine, actually, we have a garden courtyard sort of in the middle. We actually have heat pumps to air condition our lobbies, right outside the lobby and into the garden. So in a case for a domestic hot water heater, if it was going to be put in an area like that, like what would you say that people can't go near the heat pump? Is it that hot? And what's the noise like?
No. So actually, it is cool. So that's the air that comes out of it. It's a cold air. It's colder than the temperature outside. So it extracts heat from air. So you wouldn't really get heat. You would get cold air out of it. And regarding noise, I would say a normal conversation. I don't want to give you decibel numbers because that probably doesn't mean anything to you. But think of a normal conversation, like somebody is talking in the courtyard, not yelling, of course, but a normal conversation um, would be what we usually compare it to. However, we have ways to reduce that. There are boards that we can put up that not only seclude this from the area that people walk, but also blocks the noise. So it reduces the noise significantly by doing that.
Thanks. All right. Does the room need to be maintained at a certain environment? So I guess if you have well, you wouldn't have the heat pumps inside, right? Ever? Or do you ever have them inside?
No,
No.
never inside. So yeah, as we talked about, putting heat pumps inside is counterproductive. Well, it won't work. And it's a concern because having heat pumps inside could lead to freezing because it can drop the temperature and things can freeze. So no heat pumps inside, and you don't have to really do anything for that room specifically. The pipes are insulated, the tanks are insulated, and remember these tanks are hot, and they keep these pipes hot. So there's nothing really that you have to do with the room.
So we have two more questions that are sort of are similar to this. So I'm going to ask them one and then the other, and then it's also about how to, I guess, maintain the right climate for them and the noise factor. So the first question is, if there's a snowstorm that covers the unit's vents, would they still be able to operate, or do you sort of have to, protect them, I guess, from that? And then the
Yeah.
second question is about what is the echo factor in internal courtyards? Will lower floor apartments hear a hum? So I guess like where the courtyard is all enclosed, by buildings back to back, with probably concrete and then the brick. Are there
Mhm.
noise mitigating? Is that ever been an issue?
I mean, again, we can have um, these soundboards that mitigate that noise, um, and reduces and makes the noise directional. So the lower floor apartments don't really hear it. I mean, there's city noise. I think how you would compare it after the soundboards, it would be similar to um, what you would hear from the street that is adjacent to you. So it's something similar to that. So the soundboards do a pretty good job of mitigating that noise. And the other question regarding snow, this is very typical engineering practice and installation practice that we raise the units to protect it against snow, and any snow that accumulates on top that easily blows away with the fan. And these units, you gotta remember the way we design them, they're pretty much running all the time. So there's no, we want to maximize the money that you invest in these equipment. So we design in such a way that these units are continuously operating throughout the day, and that's how they like to operate. So you don't want to have a situation that the unit comes on, comes off, comes on. Comes off. So it's more of a continuous operation.
And that would be true even when there's no water draw, right? Because it's going into the storage tanks to maintain them. So like even at night, they would be running. Is that correct? Or
Yeah, that's exactly correct. So some people like to take a shower. There are load profiles that we look at for multifamily when we design the systems and size the storage on typical usage. In certain larger buildings, we like to monitor the water usage and meter the usage to get the exact profile of the usage of the building. Um, and we have a graph that shows how you use hot water, and we design based on that. So in a lot of cases that we see, um, there's a big demand at the end of the night, people taking shower, doing laundry or whatever, and there's a big draw. Right after that draw, the tanks need to recharge, and that recharging happens overnight.
all right. There are 3 questions left in the Q&A right now. I'm going to ask you 2 of them, and the last one is about new heat pump technology. So I'm going to hold that to the end and then ask it then so that you can go on to the next section. So the next question is, what preparatory work needs to be done to the roof surface, particularly if roof renovation work will need to be done in the next 5 years? So I guess like, is this like solar where you should be doing your roof first, or can you put up the heat pump and then repair the roof?
Yeah, that's a good question. I mean, again, these heat pumps are not, um, I wouldn't say we are going to have a heat pump farm up on your roof with many units. It's going to be, um, we want to minimize the number of units we use. And in most cases, they can be moved later. So I wouldn't wait until you do the roof, because um, it would be doable to move the heat pumps away from the area of work and then bring them back. However, that would be a disruption to the water supply. You can do emergency water heating using some other method while you do that. These are very specific cases. In terms of supporting the roof, if you're redoing your roof, it's good to build the dunnage, the support structure for placing the units on your columns and beams to be able to support the weight of the unit. So that's something that roofers can do. Um, HVAC guy, metal work guy can do the dunnage, and then they would use pitch or tar to redo the roof around the dunnage. So there are different ways, and good thing is that solar actually works really well with water heating, because we have designs that, again, we talked about battery, right? So water is the best battery. It's better capacity than the battery that you have in your phone in terms of um, energy saving. So we can couple your solar with your water heating. So while you produce the electricity, you're charging your tanks, and you use that free electricity that you charge in your tanks throughout the day. So I think that's a very good combination, and I suggest that to whoever is considering it.
And the last question before you move on now is, do the units use variable speed drives?
Absolutely, they have to, all of them.
Okay.
That's where they get their efficiency. Yeah, okay. Yeah, talking about this next section is mostly some examples, as well as talking about electric service upgrades. Comes up a lot. So if you need electric service upgrade, which is rare for water heating, this is the typical timelines. If there's no upgrade needed from the Con Ed side, we would know in less than a month, and we would hear back from. If there is an upgrade, they have to do a new vault. Sorry, there's no vault needed, and they just have to upgrade the service to the building. 4 to 6 months is their timeline, and we are going through this for a space heating project right now. That's the typical timeline we have. And if they have to upgrade the vault in the street, down under the street, very rare, 18 to 24. This is like for the case that you're doing induction stoves, you're doing your heating upgrade and water heating all at the same time, and you have no capacity, then they do this for multiple buildings in that street. So this is like a very rare case. This is the chart that we use to determine and show which buildings are good candidates for water heating, just simplifying things. And I think most of the audience here fall into the category of 25,000 square feet and larger. So for large buildings and the ones that have pending fines from 97, pretty much all cases it makes sense to look at upgrading to heat pump water heating. So again, large buildings, a lot of them have that type of boiler, larger boiler that is very, very wasteful. Even if you have a dedicated water heater, since you have fines pending, it is good to look at reducing those fines with the heat pump water heater replacement. The fuel type also makes a big difference. Oil is much more expensive than gas, and it makes the financials much more attractive. Moving to energy costs, we talked about energy costs before a little bit. Note that this is cost of heated water. So we are comparing how, let's say, a gallon of water is heated, and just comparing different fuels between each other. This counts in the efficiency of the systems. The traditional oil and gas, they have 60, 70, 80% efficiency, and heat pumps have 400, right, per unit of efficiency. So that comparison brings heat pump cost of running heat pumps much lower than the others. Gas, again, is relatively close, but as you know, oil is very expensive, and it makes it a no-brainer to switch to heat pumps. Just some examples, small building example, and we do a large building example after. Just showing these differences. This is a building that we have a proposal out. They're considering our design. 16 units, 15, I mean, this is commercial at the bottom, 10,000 square feet. They're using oil number 2, and they have one boiler for both water and space heating. So the power for this building is 225 amps, 3-phase. And what they're using right now in the building is about 120 amps, three-phase. So the leftover is about 105 amps. And what we're using for the water heating is single phase actually. So 22 amps single phase compared to 105 three phase. That's way more than what we need for this upgrade. And it's a drop in the bucket. So no electrical upgrade is necessary for this. For that building, the analysis that we gave them, this is from their cost of oil. We collected their oil bills basically, and we calculated based on our design and the oil bills that they had, the payback for that system with the incentives is about 7 years, which is well within the warranty of those systems. I would say half the years, and you would have another 7 years for the warranty. If that boiler that was on oil, if it was gas, because it was a small building, the payback would be 23 years. But again, that's a small building. As you can see in the next example, it would change significantly. I don't think there will be a lot of questions here, Rebecca. Should I move on?
Sorry, we do have one question. And then we still have the other question about heat pumps for the end. Can you provide more information about the metering or monitoring system? You mentioned that you metered the use, I guess the use of water. There is no separate metering for water use in each apartment at our building, only the singular use for the whole building. So how, I guess the question is how you determine.
Yeah, that's a good question. We actually don't care about the singular use of each apartment because the system that we provide is providing water to all the units. Like it's a central heat pump plant. So what we care about is how the whole building is using water, aggregated basically. So we monitor, we put sensors on the hot water lines going up to the building, and we collect that data to understand how the whole building is using water. What are your habits? We have general data from other buildings and the studies that they've been doing for years, and we use that for certain size projects. But for larger ones, we want to be um, as accurate as possible, and we monitor those usage patterns. Again, usage patterns. Again, if it's a building that has a lot of 9 to 5 type workers in them, it's a different pattern than one that has a lot of people at home with a lot of children. So these are different patterns that we use in our design to make sure you get adequate enough hot water for your living habits. Any more, Erica?
Sorry, there is one more question. But I think maybe you're getting to it now. I don't know. So just tell me, what about savings for large buildings that have gas boilers?
This is exactly it. Good
Perfect
segue.
timing.
So this is a building that we've been working with them for more than 2 years now. And we did their space heating. Now they asked us to provide water heating solutions. So that's their next phase for water heating. So 109 units, 108 is residential. It's in Brooklyn. About 150,000 square feet. This is a building that is facing significant 97 fines. And we talked about this building in more details, why it's in a place that it is now. I mean, it's reducing it, they're fixing it. But they have more than 200,000 starting 25 every year in fines, local law 97 fines. And The water heating emission only, it's 630 tons just for water heating. Using gas, they have two large oversized boilers, and which is the cause of all the problems. And they have heat exchangers to produce hot water. The emissions for this building for 2024 to 29 is 960. Just hot water only, it's already getting it to the close to the limit. And for 2030, the limit is 580. Just water heating only with the gas boilers they have already exceeds that limit. So you can see how inefficient that water heating system they have is, even with gas, that is causing this issue for this building. This is from their utility bills. We have more than 3 years gas bill for this building. We have a lot of data on this building. We've been working with them for 2 years. We did an analysis for them for the heating MMBTU throughout the year. You can see the blue is for space heating, the red, the orange is for water heating, and the green is the proposed heat pump. As you can see, the orange increases in summer months and becomes the dominant energy use in summer months. And the heat pump basically is a fraction of that, but not only from the efficiency of the systems, but also reducing that wastefulness that we talked about early on in the presentation. So cutting that wastefulness of the boiler and going back to an accurate, to the point design is the key. And we are proud to present that type of design to the buildings that can cut down the emission and only use the amount of energy that you need. So putting this into perspective for this building, the numbers are 100,000, about 100,000 for the utility used for water heating. And after doing the upgrade with heat pumps, the savings just from the gas savings would be around $50,000 to $80,000. That's the range that you would get for switching to heat pump water heaters. And that's just from utility saving, gas savings. Because again, we talked about the boiler being oversized, and now here we are reducing the gas usage and the utility usage by switching to heat pumps. So without fine avoidance, and we're not talking about local law 97 fines in this range, without fine avoidance, just from utility, it's about 3.5 years of payback for this new system. But if we count the local law 97 fines that they would avoid by this switch, the payback would drop down to about a year or even less. So as you can see, and this is not even counting the beneficial electrification in this calculation. So as you can see, even without 97 fines, this is still a very favorable upgrade, and the paybacks are very attractive. The fine avoidance that we are calculating here for until 2030 is about $10,000 per year being avoided by this switch. Summary: what buildings are good cases for this crowd? I would say all buildings. Larger buildings are part of this audience, and buildings that face fines from 97. If you have dedicated hot water, I would say let's talk about it. Let's see the building. Let's see if this is a good fit. But otherwise, I would suggest this for pretty much most buildings that we see. We do the analysis for you so you can make the decision with eyes open, and we offer the best design in the market. So um, we can show you the value that we bring. So thank you very much for the time that you spend with us today. I'm gonna stay here for more questions towards the end, and let Rebecca take the wheel.
Thanks, Sina. So we have two more questions. One is, what about a large building, 400 plus units with new 2 years old gas boiler and no fines until 2040? So the gas boiler is pretty efficient. Are there still any savings from switching to the heat pump for water so that we don't have to use the boiler when we don't need it for space heating?
Exactly. So, yeah, that's I would say depending on how your setup is, 400 plus units. I don't know if you have one boiler, you have multiple boilers. Some buildings they break it down. Depending on your scenario, you may again see savings like this building just from fuel savings. So the fuel saving alone for this building is justifying that 3.5 year payback of this new system. So if it's incorporated with your space heating and it's a relatively large boiler that is doing both, then you would see significant saving just by switching to these heat pumps and separating it from your um, space heating.
Whereas I guess if they had two boilers and that one was running during the summer only and they used both during the winter, then it would be less of a savings, right? Than just a one.
Yeah.
Yeah.
Well, it's interesting. This building. This is actually doing that. They have two boilers. They shut
Oh,
down one and they use one for water heating, and still they have that much waste because these boilers are just massive for a building of this size. They're significantly oversized.
okay. And the other question, which I've been holding, is, are there any A to W heat pumps that are coming online within the next 4 to 5 years that will both work with existing baseboard heating systems and provide hot water?
Yeah, there are combi systems out there. I mean, this is more of a, I would say, technical question. So the person that asked that, I think we're gonna have a good conversation. Maybe reach out. We talk. I enjoy talking about these things, so feel free to reach out. We do a more in-depth conversation.
Great. I guess there are no other. Oh, here we go. Are there currently NYSERDA incentives
Absolutely,
for
there
this?
are big ones. I've never seen this level of incentives for water heating ever before, and the technology also have matured significantly. We just secured um, custom incentive from Clean Heat and NYSERDA for one of our new projects using one of these cold climate heat pumps. Yeah, I would say Efficity, just with the background that I have working with Con Ed and utility programs, we we're specialized in heat pumps, and we make sure we get the maximum incentives for your projects, so you get the best deal.
So are most of the incentives through the Clean Heat Act for the heat pumps? Is that where they're coming from, the majority of them?
Yeah, I think I would say it's half from NYSERDA, half from Con Ed Clean Heat. I mean, they're all from NYSERDA, but NYSERDA has direct programs also.
And
So
do you know, I mean, we're going to have a full class on this coming up on August 14th, but just curious if you know, would the hot water heat pumps, would they, for just hot water, would they qualify for the IRA individual tax benefits, the 25L or 45L, whatever that program is?
We can get that for the IRA tax incentives for you from different channels. There are ways that we have secured incentives for other buildings. For co-ops, it's a little bit because of the tax structure that you have. It is different from individual or commercially owned buildings, but we have found a solution, and we have claimed that for through. I mean, we are still yet to claim it at the end of the year, but we have secured it um, through certain ways that we have. We work with different partners that are specialized in these areas, and there are requirements by the IRS that certain standards need to be met during the project. So we know all of the structure of it, and we know how to get those deductions. So I would say it's really project dependent, and co-ops they qualify for a certain
Right.
versions.
Right. Just before I ask you to go on to the next slide, one more thing. I guess when you first look at a building, you would be able to tell whether or not there's sufficient capacity to do the work, right? And as part of the initial,
You mean the electrical capacity?
Yeah. Right.
Yeah.
Yeah.
We would.
Before the project gets started, you would know whether or not
Yes,
there's there's sufficient capacity, and also you would have a good idea from the benchmarking reports in terms of energy usage what type of savings there would be. Those numbers usually don't vary too much from the estimate. Is that?
We use the benchmarking a lot for fine avoidance numbers. If the benchmarking sometimes is hit or miss for the water usage, as some buildings report it very accurately, which is great. We use that for initial assessment. Otherwise, we do some estimation based on our just engineering knowledge and the past projects to get an idea of the water usage. If you're asking about the energy usage, we collect bills, and we use 84 to calculate the savings based on 97 and the savings from utility.
Right.
So it's a combination of multiple channels.
Right. Thank you. Okay, so if you have other questions, we will be distributing the slides tomorrow morning, so you'll have Sina's email address and you can forward your questions to him. I just want to quickly bring up that we have a lot of classes coming up this summer. Our discussion groups are meeting in August. We have the roundtable series, where we'll have 6 professionals to answer questions: the attorneys, the accountants, architect, engineer, and property manager and insurance person. So please feel free to register for that. And then on August 14th, we'll have a full class on tax credits that you can obtain if you do work such as this individual, off your individual tax bills. Thank you so much, Sina. It's a fantastic class, and we really appreciate your time. And thank you everyone for attending.